All right, what's up, everyone? Welcome to another episode of the TWiML AI podcast. I am your host, Sam Charrington, and today I've got the pleasure of being joined by Disha Singla. Disha is a senior director of machine learning engineering at Capital One. Before we dive into our conversation, be sure to take a moment and hit that subscribe button wherever you're listening to today's show. Disha, welcome to the podcast.
Hey Sam, thanks for inviting me here. I'm very excited today.
I'm super excited to chat with you as well. I'd love to get started by having you introduce yourself to our audience and share a little bit about how you came into the field of machine learning.
Sure, Sam. So I joined Capital One earlier this year as a senior director of machine learning engineering. Before Capital One, I have had opportunity to work at some great companies like Intuit, Sony, Newstar, etc. So my career, I started as a full stack engineer, but I had a deep love or passion for data. So the whole end-to-end life cycle from collection of data all the way to driving meaningful insights. So that's how I organically continued to grow in this role. And here at Capital One, it's a great company. I joined earlier this year, where I'm leading a group of very talented data scientists, machine learning, and software engineers. Our group is called Data Insights. We are working on something that's very close to my heart, which is democratizing AI, democratizing ML by making ML available to everybody. So, our team has built reusable libraries, components, and workflows and have created a platform which allow the citizen data scientists to drive meaningful insight using our various offerings within Capital One.
Awesome, awesome. Can you share maybe an example of well, a couple things. First, when you think of a citizen data scientist, what's the kind of archetype for that person? What are they typically? What's their day job, so to speak? And then, what are some of the things that they have done with the tools that your team is providing?
So to me, let me take you back like 5 to 7 years, right? Back where everybody wanted to build models, right? But not everybody can formalize. So people grow, they explore data sets, right? Or they know that there is value in the data, so they want to explore that value, they want to use those insights to drive some meaningful decisions. So the way I would like to think is to categorize data scientists are the people who have this formal education of ML, of stats, whereas the citizen data scientists in my purview in my point of view are the people who are analysts who have done something with data but they do not necessarily are keen or build models, or they are the engineers who are data engineers or software engineers who want to be able to do ML. That's how I would like to think about it. So now when it comes to our tooling, if you think about what we are doing is we are building reusable components. What we are trying to do is that, let me give you an example, a concrete example, and that it would help. So the way our team is working on, we have built like reusable libraries, workflow components, and algorithms, which are in the field of monitoring and forecasting. When I say monitoring, we are talking about time series anomaly detection, change point detection, root cause analysis, and time series forecasting. So when we talk about regular data scientists, they want to build bespoke models, right? Everybody wants to like quickly spin up a Jupyter notebook and then do some research, do some analysis of data. Then they want to build the features, they want to train the model, deploy the model, and do a bunch of things and drive the insights. Where we differentiate is our audiences, they want to do something quick. They might not have strong engineering background or data science background, but what they know is where the data is, what is they want to drive quickly using our tools and components. So for example, right, let me give you an example of forecasting. So we have workplace solutions team. They want to help our associates with our hybrid work environment. So they're using our solution to kind of forecast how many people are going to be returning back to work on which day, how much the kitchen stocking has to be done. And now, so that's kind of forecasting. But now let's think about the other thing, which we are very proud of is the transactional fraud, right? So this is, for example, right, a third party, our internal team, which is a third party fraud team, they came to us. They were looking for some kind of solution to identify the anomalies in the fraud and automatically create defensive to mitigate the losses and reduce the customer friction, right? So they partner with our team. They come and say like, hey, we want to do A, B, C, D, E, and what we help is like we help them by creating this workflow, which is under the hood is a DAG, and then what they do is they work with us. They say this is where the data is, and then what happens? Let me give you a little bit more detail. So when a transaction is marked as fraudulent, right? It is then analyzed by our solutions in a batch mode. And then what we do is the segments with the highest anomalies are flagged. So our anomaly detection algorithms kick in. They say this is the segment with the highest this is the segment with the highest anomalies. Then other set of algorithms kick in which say that okay, this is the change point happens starting when did they start noticing the change. And then there are then after that they go and see the root cause analysis, and then what happened, the automatic rules get generated which then get applied to the real time systems to prevent the future fraud. And Sam, also, if you know, with any anomaly detection, one of the biggest challenges is minimizing the false positives. So we have built an there. With what helps is so algorithms are open source and proprietary algorithms. So what these algorithms do is that we have intelligence built in, which also minimize these false positives. For example, right, if I go for a dinner with my husband, right, a nice dinner, and if my credit card gets declined after that, that won't be a good thing, right? So
Not
it's
happy.
not happy. So it's kind of very important that we are not just having those algorithms built in, but we are also like helping to use the results of this algorithm, help with the real time systems to mitigate future fraud, and also give a good customer experience and reduce the friction, because false positives are big concerns.
You mentioned some things that I think of as existing in different kind of layers of a stack. You mentioned anomaly detection and forecasting as kind of these higher level, almost primitives that maybe you offer to these citizen data scientists. You also mentioned workflows. Are has your team, and you mentioned as well open source and proprietary algorithms. So has your team kind of curated a collection of these algorithms for forecasting and anomaly detection and provided a platform that allows them to create these workflows, and you're supporting them in building the applications? Is that the way to think about the way your team engages with the client?
Yes, you said it very right. So let me also give you. So what is important for democratizing ML and how we are helping is we are focused on the key for us is no low to no code. So what we are doing is, yes, we have an internal platform which is very scalable, built on Kubernetes. We have this sophisticated orchestra. We have like this sophisticated workflows and libraries built in. So yes, our the way I would say is our reusable libraries are sophisticated packaging of, as you said, these algorithms which are open source and proprietary algorithms which you have built over time by researching using white papers and everything. And then under the hood are the low level DAGs on which we have an abstraction built out. So we help our customers through providing UI where the customer just goes. They just say, okay, hey, this is in the S3 bucket or in the Snowflake or wherever myriad data sources we have where the data sets are. Then they provide us some parameters that okay, I want this, I want to drive this, and these are some of the features which we think are important for us, and then this is how often the model needs to be retrained, and this is the output sync, whether the data has to go to an S3 bucket, whether it has to go through Snowflake or whichever are the other Capital One data and Capital One data systems are. So we kind of collect all these parameters, and under the hood, instead of now this person building the whole ML pipeline, which is very sophisticated piece of coding and not easy, so we do it under the hood for them. And what happens is that we have governance and rules in place. So now what happens is, because they just choose the templates, they provide the parameters under the hood, we have all our algorithms reviewed by our model review office, we have governance, we have everything in place. So the time to market for these solutions for our internal platforms is like very, very quick.
And what roles do you have on your team supporting all this? Do you have everything from data engineering to ML engineering to data science?
Yes. So the way I'll just share something interesting with you, right? So for me, what an MLE encapsulates, like, so an ML engineer is a good mix of data engineer, software engineer, data science, and like business acumen, and be able to like cloud skill set. So now to answer your questions, our team is like data scientists, software engineers, and machine learning engineers. So they have all the necessary qualifications to build this end-to-end sophisticated system.
Right, right, right. You mentioned that the platform is Kubernetes based. I recently spoke with one of your colleagues, Ali Riddell, whose team, I think from that conversation, they're very focused on kind of low level Kubernetes based environments for machine learning there. Can you talk a little bit about how, what your team does and, any intersection points or how the approach your teams take and how they differ?
Of course. First of all, I heard you. I am, as I said, I'm a huge fan of your podcast. So I did listen your podcast with Ali, and it was a great talk, by the way.
Awesome.
So
Thank you.
the way I would like to answer this question is the way I think Ali's team and our team is doing is very complementary. What we are doing is we are building a coherent ML ecosystem at Capital One, catering to all kind of personas, if you will. So the way Ali's team is working on is building a sophisticated system for the regular data scientist, as is done in a lot of companies. They're providing a system for regular data scientists who want to spin a Jupyter notebook, who want to do feature engineering, who want to train their model, who want to deploy the model, who want to create an artifact and like deploy it, do hyperparameter tuning. And where we add value, or our team is adding value, is democratizing ML in the niche, as I said, around monitoring and forecasting. Where we add value is by building providing reusable libraries and components and workflows, right? For example, right back in the day when I was a data scientist, what I would do is like I would spin up a Jupyter notebook or an IDE that I like. I would like to do feature engineering, spend like long cycles doing feature engineering, and then training, and then hyperparameter tuning, and then creating an artifact, creating a Docker image, and then deploying it.
I think you mentioned bespoke earlier, like a very handcrafted process of creating this model.
Yes, which is like solving a particular problem. But what we do is our audiences are the people who want to drive quick insights, right? They don't necessarily care about building a model. They are looking at, okay, can somebody put a solution for us where we can minimize the transactional fault? Can somebody help us like where we can detect anomalies in the system? So this is where we differentiate.
And are the users of your platform are there, so they build these models using the algorithms that you provide and the reusable components as you mentioned. Are there is their goal to productionalize them in the same way as the traditional data scientists? Like we think about the traditional data science or and machine learning, like you want to eventually get a model into production, maybe behind some API or even if it's batch, but like it's in production. Whereas more of an analyst role, they want to get the insight. Maybe it's to generate a report as opposed to have a model in a production. I'm curious, how is that distinction significant to your users?
It is because at the end of it, they want their own API that they want to hit to drive the insight. So where so yes,
So there is this desire for productionization of what they're doing on your platform.
yes, I'm yeah. We have like many productionized use cases. So whatever examples I was giving you before about the third party card fraud or the workplace team, those are two of the many production use cases that we have. At the end of it, yes, there is this API that they hit, or it is hit automatically by what we have built in the pipeline, which is kind of giving them the predictions, or that they then use or surface up the stack for the business to make necessary decisions.
Okay. Okay. So in a sense, the just because they're these citizen data scientists, they still need a fairly sophisticated set of tooling to support what they want to do, because they want to do a lot of the same things. They just don't necessarily have the expertise or the desire to tweak all the parameters that the traditional data scientists might have.
Actually, they need more sophisticated, because now the onus is on our team, because the contribution from the citizen data scientists, they don't know if they want to use the dice coefficient versus the binary coefficient, right? So the onus is on us to kind of build that sophisticated offering for them, that they get the results, if not better, than same as if somebody from their team would have created this handcrafted model for them.
Got it. Got it. Yeah. Yeah. You mentioned in talking about the fraud aspects of both batch and real time, and when you talk about monitoring and anomaly detection, real time comes to mind there as well. Can you talk a little bit about real time requirements for the kinds of things that your users do and how you accommodate that?
Sure. So I'll give you example in general also, first of all. So you know how the technology is changing, correct? And I represent an average internet user. So if I'm on a website, I don't get what I need to see in couple minutes, I will leave. And some, we know that there are so many platforms, there are so many e-commerce systems. So machine learning has to be fast. And what that it has to be fast. For example, right, if I'm on a e-commerce website, right, I need it needs to tell me like how do they differentiate their products. There are so many vendors on that one, right? And then if AI is and ML is getting smarter, right? If I'm leaving the website, they know they want to intervene to keep me there. They want to upsell a product. So what's needed is something that is very, very fast. So the way models have to be is not only that they need to be statistically strong models, they need to be fast also. And what happens is like many a times I see that, and even when I started in my ML journey, the focus was mostly on building the sophisticated models, right? But a lot of focus doesn't go into how to make them optimized in the sense like fast. And also it's a whole stack if you think about it, right? So you have a model which is fast, then you have a platform which is able to like surface the anomalies or surface the outputs of the model fast. Then another interesting thing that happens is that these things are ultimately like, but if you see the entire stack, you might have a UI layer, you might have a business layer, you might have different layers which are owned by different teams. So you need to have like an overall system which deals with the TPS 99 SLAs and everything, so that the time in which the whole stack responds in like few milliseconds. So what am I trying to say here is that over time, and coming from the engineering background, the way I like to see a model, as we talked a little bit before also, is like a piece of software or an API that's on production. So people need to focus on it. If it's just a piece of software, right, forget about the model development life cycle. They should at least think about it as a software development life cycle, and it should go through the same engineering and operational rigor. Real time makes it more interesting, because now we are talking about distributed systems, we are talking about TP99, we are talking about SLAs, we are talking about uh, the cost effective cost usage. So because there are so many things in the stack and they are so interdependent, so real time becomes kind of like challenge these days. So what we are doing is in our system is that most of our use cases are batch models, but there are few which are real time systems. So what we are doing is like we have put in, so if the data is coming right in the magnitudes of gigabytes or something, this is like mostly for training. But when it comes to like real time, we are trying to listen to the event bus, so that we can listen to the, if some of our features are coming through the event bus, right, we need to factor that in. We need to have our model respond in microseconds or like 100 milliseconds or something. And then we need to make sure that our DAG, we are doing like parallelization of systems. We are having our DAGs like work in a way that we can parallelize depending on how the feature vectors are created and everything. And then so a lot of focus is right now on across the, not just like the model has to be good or the algorithm has to be fast, but the whole pipelining that we are doing, it has to be like super fast. And also the teams who are receiving it, they have to work with the same rigor as we are working, if they want to have like within product intervention or something.
Are you doing much with serverless technologies for inference?
We are doing a lot of work which is serverless, but a lot of work which is our own proprietary internal stuff.
Okay. Okay. And you mentioned You mentioned event bus. So the idea is that you've got some model server that is listening for events on an event bus and then hands that to some model for inference when it sees the appropriate things.
There are two ways to do that, Sam, actually. So we can read through the topics in real time. Or second thing is also that's happening is that if a team has a our partner teams have sophisticated feature platform. So what happens is that they can read from the topic and put it in the feature store from where we can listen to those features or we can gather those features from the feature store. So both works.
Okay. And so I'm trying to get at other, I guess, other challenges that you run into when you're supporting these real time use cases. It sounds like real time in general is something that you expect to grow. There, you're doing a lot of batch, but you're expecting to see more real time over time. What else do you anticipate having to overcome as you take on more of those use cases?
So what we're also going to do is that for real time systems, right, we need to have more control on our overall deployment, our workflows, right? So what we are also doing is not just for real time, but what we are also trying to do is, as I said, we are trying to centralize the build an centralized ML ecosystem at Capital One, right? So not necessarily what my team is doing and what Ali's team is doing. I see at some point we are going to work together on on building something like a more sophisticated real-time serving, a more sophisticated integrated batch serving. So we are coming together. We are trying to do the best practices around uh, federated learning, automated learning. So as the system is learning, it's training automatically, and then it's providing better outcomes or better predictions. So we are on that journey. There are a lot of things that we are working on, and I'm pretty sure that we will be able to be almost real time. I don't think any company is like fully real time, but that's just me.
Sure, there's always latency somewhere.
Yes.
In introducing yourself, you talked about a pretty wide variety of organization types that you've worked at. Can you talk a little bit about how tackling the kinds of challenges you're discussing here and the use cases that you're discussing here are different at a financial services firm like Capital One relative to more of a tech oriented firm, a startup? What are some of the things that you need to think about that you haven't had to think about at other places?
Yeah, very interesting question, Sam. Let me tell you. So, as I told you, right, I grew from full stack engineer to now being a leader in the ML space. So, I've worked in companies which are like startups to companies which are like Capital One, who are like highly regulated or into it, right? So, the way I would like to answer this question is in two ways, right? So, if you are working in a startup or in any company who are in its initial ML journey, right, you don't think about governance or regulation or compute cost, right? You basically you don't have a whole lot of rules in place. So what you do is like, oh, I need this, oh, let me get this data set and let me just quickly build something. So you feel like very empowered, you build something quick and snappy. But then when you grow in your ML maturity, that's when you see like, oh my god, so many issues start surfacing up. Now your cloud costs are out of order. You have like a data scientist who spun off a big cluster with 3 GPUs to train a model and forgot to shut it, right? And there are multiple teams who are doing that, right? So what happens is like your cloud costs start going up, and then you end up seeing that different teams, there are 10 teams in the company and they all have their individual ML platforms or pipelines. So then the leadership has to think about, and then there is no governance. They are not thinking about PII, SOX compliance, GDPR, CCPA. As you said, I've worked in regulated companies, so I can tell you all the names, right? So then those things kick in, right? So that's why, so there is this thing that we're now eventually there is a tech debt that's get created, and then the leadership have to make some arduous calls around like, hey, we need to throw away work, or we need to merge, or we need to converge. But now working in companies which are in the ML maturity space, right, and especially the regulated environments, what I've seen being a machine learning engineering leader is very important to standardize the tools. It's very important, not just the tools, your processes, your algorithms, right? What this does is like, now these companies are big companies which have a lot of ML associates, data scientists, MLEs. But what it allows it helps them to come with a centralized process where they can identify. They have mechanism. They know how the ingestion pipelines are working. They know how what's the best way of getting the data. There are scripts, or there are like scripts in place where you just cannot spin off an EC2 by going to your control plane. You need to follow some rules and practices, right? And then as I'm talking about governance and auditing, so what happens in like companies like Capital One, which are highly regulated, you need to be able to store your training runs, the input and output parameters that were part of the model, right? So that if needed, you are able to recreate the model. You need to be able to tell the customer that if you get audited, why such a decision was taken from the model. And then it's important that you have governance. Like at Capital One, we have our model review office, right? So it's very, so that's where I see the difference. But again, I'm not going to shy away from saying that like all these things add like a lot of processes in place, which sometimes people don't like. And what happens is like these procedures and practices in place, it at time create a lot of dependencies. And then like your time to market or your time to go to production like slows down. But honestly, on this one, Sam, trust me, on this one, it's much better to be a little bit late than to go to production and then have to deal with the production and compliance issues. It's not fun to do.
Hmm. Meaning, it in your experience, it's better to have those processes integrated into the development of your model as opposed to trying to bolt them on at the end.
Yes, yes. And also, uh, please follow the processes, because everything looks nice, but if you ever get audited because your model behaved a certain way, or you have to go through a compliance issue, that takes like weeks or months to work on them.
You mentioned this, the need for reproducibility, and the idea that you're taking all of your training inputs and training data and kind of storing that away so that you can reproduce these models. Is that based on internally developed technology, or do you use some third party tool to provide for that?
No, internal build technology. Internal build technology. I can talk a little bit more about it, right? So, uh, in storage costs are not that great. Storage is cheap, right? So, in without taking name of the company, right, I've worked in various companies like where uh, logging is, or instrumentation is very very important, right? You need to instrument what are the features coming in. You need to instrument what is the model's output is, and then other things which go in the part of like pre-processing or feature engineering, so that you have all that data. So now if you get a customer call saying that, hey, you said this and I went through this, and then maybe that's not the right decision for that customer, then you need to be able to go and see exactly what happened. And it helps you by, for answering the question of the customer, but also helps you reverse engineer better about what went into it. And you know, like how explainability and responsible AI and all those things are important. So a good instrumentation of the whole, how much ever you can instrument, I think it's never enough. That's just me. That's my engineering mindset.
On the topic of engineering mindset, you kind of alluded to a level of robustness that's required, which makes me think about like testing and the importance of that. And that seems like something that over the past, I guess, year, 18 months, like we've kind of gotten to the state in machine learning where we're, trying to apply the same level of rigor that we've had for traditional software to model testing. Have whole companies set up now around model observability as one kind of expression of this desire for testing. Can you talk a little bit about how you approach that for your platforms and teams?
Sure. So what I want to start by saying is that what I alluded before also, so a model, when it's on production, it should be treated as a piece of software or an API, but with more sophistication now, because there is the involvement of the data piece, right? Today, today, even though you're say we are thinking about like, okay, ML ops and testing and scalable models, still I personally feel a big chunk of time goes into like creating a sophisticated model which has like a high statistical efficacy. We want to spend rounds of cycles doing hyperparameter tuning, feature engineering, and everything. I think defensive coding and exception handling, they are key, right? If anything else, if the model is a piece of software, it needs to go through the same rigor, right? It needs to have like end-to-end testing, integration testing, unit testing, load testing, A/B testing. But what makes a model special is because there is this data component. So data quality testing is the key. And you know what? It's interesting as data scientists and machine learning engineers, sometimes we think, oh, I have spent this humongous cycle of building these features and I've dealt with everything. Now my features are good. But that's where I think the mistake happens. Because, see, we are the one who are closest to the data scientists and ML engineers. So I think the onus is on them to write as part of their code around the defensive coding or data quality test. There is a high ROI in defensive coding, right? Or preventive coding. As I mentioned, different types of coding, I think data quality testing is the key. For example, right, some of the data quality testing that we are doing and then I think is value add is checking the data type and the values of categorical data. Another one interesting one is the is the cardinality shift, right, where there is a certain shift in the distribution of categories and bam, your model is predicting like it has predicting a particular category. Data leakage and drift over time, and something which is very close to my heart is missing data. There are so many papers around how you want to impute data and then what are the techniques.
Well, particularly for forecasting and anomaly detection, that's going to be a big deal for you.
Yes, but then also we need to know where we draw the line. Let me talk a little bit more about it, right? So, Sam, the feature vectors these days are like highly complicated. They are based on myriad data sources, right? So, I think we need to have some guardrails and thresholds on how much and which features should be allowed with missing data, how much can be imputed and what we should not be imputing. So that's where the responsibility part comes in also. So, and at what point the model should just like raise an exception and be like, hey, this is not adequate for me to make the predictions.
Meaning, what I'm hearing there is it sounds like you're speaking to examples where okay, you kind of do the thing that you learned in school, right? You have missing data, we're going to impute it. But if you're not paying too much attention, you could be imputing half of your data and you really don't know what your model is basing its decision on. It's the signal to noise is not high enough.
Yes, exactly. That's what I'm saying. Like, data science is a privilege, but it's a responsibility also. So, we need to be able to draw a line around what can or cannot be imputed. I'll give you a very simple example. And the reason I'm giving you this example because I have hit it multiple times at different places, right? So, demographic models, we build a lot of demographic models. And most of the time, zip code is one of the important features, right? From which you can drive, you can have like, okay, short distance from this place, long distance, or get bunch of other demographic data. I've seen many a times the model is expecting a 5-digit zip code, but sometimes the users, if it's a free text, they pass in a 9-digit, and then the model fails. So what I'm suggesting the people is like, hey, it's only one or two lines of this extra code which should be part of the model or the pre-processing code, and it can just save us like bunch of trouble for our use cases, right, Sam? As I said, like we focus a lot on centralizing our engineering and operational rigor code standards across Capital One. So we have standards for coding, we do peer review, we do unit testing, integration testing, end-to-end testing, cross validation, and like every other company, our data quality testing is evolving too. So some of the best industry practices that I've seen is like creating synthetic or golden data sets, right? And then you revisit them when you find the edge cases. Other thing we do is like scenario based testing to mitigate output or surprises. Recently I was also reading about how we people do randomizing or first testing in software engineering. That is also becoming like important in the data science or ML world. Yes. So those are some of the best practices we follow.
And thinking back to kind of your role in enabling these citizen data scientists. I'm imagining that these are things that you want your team thinking about and building guardrails around or implementing, but not necessarily, that's a lot of cognitive burden to put on a citizen data scientist to think about, this and that and not impute too much data and that kind of thing. Like, are they things that you're able to kind of isolate as concerns of your platform as opposed to concerns of the end user?
So what we do is, as you said, we have guardrails built in place, right? So where we are today, we are doing UI and API based integration. But where we want to be is that, which we are working towards, is like the user just goes on the API, go on the UI, just say, "This is my data," press a button, and after that, we take care of everything, right? So at every pace, we want a guardrail. For example, let's just say, I'm just going to give an example, right? Let's just say this user is asking us to train the model with like some 50-60 gigabytes worth of data, right? So we want to be able to do some testing. We cannot do like this whole kind everything, but we want to have some, and we want the user to tell us like, okay, for think about like as a regular business use case, right? In the bespoke world, what happens is, uh, the business analyst or the product sees something is happening on a specific page, or something is happening, they think, oh, there is definitely a signal, let's go to the data science team now and see if we can have like an ML intervention, or like or an insight built in during this journey. Similarly, when people come to us, they have already seen, oh, there has been this fraud, or hey, how they are being using something based off Excel for the associates to return back to work, or sorry, in the hybrid work environment, right? So what's happening there, right? So they have some signal. So our hope is like we'll be at a place where they just go to our UI, they say where the data is, which are some of the critical features that they need, and then we have some based on like our learnings. As we are learning every day, we are going to like, okay, for this particular feature, these are important. We put the guardrails that, okay, this kind of data quality checks are in place. This much data needs to be there, especially as you said, anomaly like time series, right? What can be imputed? What's the best way of imputing? We do some kind of data cleaning, wrangling, show the features, then have the user take a look at it and say like, okay, press the next button where training happens. Then they deploy whether they want to go on batch versus the real time. So that's the end state that we are working on getting today.
Can you talk a little bit about, we've talked about use cases and kind of technology thus far. You're in this position where you see all that, but you're also kind of looking the other direction in the organization, towards the business side of things. Can you talk a little bit about how you think about kind of ROI of machine learning and, getting buy-in from executives and, all the things that you need to think about as a ML leader?
Sure. So let me tell you first what is working for us, right? So when we complete a project for our internal user, right, internal client, right, we create detailed documentation around what the problem statement was, what were the challenges that the team was facing, what is the solution that we provided, what were the results of that solution, and then what's the value proposition, like what's a nibet, or like dollars we are helping in like operational efficiencies. And then we ask them as they feel okay to write some testimonials, and then what are the next steps, right? So there's also our learning, like what really went well, what could be done to get better next time, right? And then what we do is like we promote our wins with our stakeholders and leaders across the enterprise. And then personally as a leader, once we have like some proof points in terms of like ROI and better user experience, it keeps the leadership engaged. And that also helps us like, okay, now that we are preventing X million dollars here, oh, it means like if we can invest more in here to like tackle similar kind of use cases and etc. So at Capital One, what we see is that ROI can be not just money. It's like, I personally think it's three things. It's like improving user experience, generating operational efficiencies, and driving the top line growth. So those are some of the things, because not every model will give you some money directly. It could be like, oh, because we have done that, so our analysis time has decreased from a month to now like 2 days or something, right? So those are the ways. So not everything we can put a dollar value on directly.
And so have you, through your track record, have you demonstrated kind of consistent ROI such that, you know, the only thing, you would do 10 times as many projects if you had enough people to do them? Like, is talent the constraint, or, you still vying for funding relative to other potential efforts or uses of resource at the company?
Our team has established ourselves, so we are helping drive the ROI for by helping other teams operational efficiencies and like better user experience. So our leadership like trust us, and then we haven't hit like the roadblock where we go and say like we need some resources. They understand that if, but what we also need to do is like we need to have a good justification. Hey, we have done this, we are saving this x million. If we get these two other folks to help us out, we can bring in another 5 to 10 use cases of similar thing. Because as, and you'll be like, hey Disha, why are you saying two people and then 5 to 10 use cases? Because I want to remind you, like whatever we do is we do it in a reusable fashion. So yeah, so that's leveraged.
And so is your implication that you're not so concerned about talent there? You've
Okay. No, no, no. What I mean is this. See, top talent in industry, especially in ML, is not easy to get it. So you need to be able to continuously motivate them, right? Give them work which is challenging. Let them like, people want to work, even I want to work on things which I know is impacting my customer's life, right? So some challenging statements. So what we do is we continue to grow our engineers, our ml folks, our data scientists, right? And also there we what we do is like, as we are on this cutting edge or bleeding edge of ML, right? As we are improving our stack, what we continue to do is like we invest in our associates. We train them, we retrain them, right? And also we have like a strong pipeline of external candidates for which we have like a very rigorous process built in. And then I think you have talked to Brian and Ali before, and they might have also talked to you about like how Capital One is so invested in like working with universities directly, like MIT, UVA, and everybody. So we have like, and especially when it comes to ML, right? I'm very impressed with all the efforts we are putting in. We have like this ML training program. We have a product manager ML training program. We have like a PhD program. So Capital One is doing a lot to keep its associates on this bleeding edge of ML technology. And also, we have this DEI, like diversity, inclusion, and belonging kind of culture, where we are also trying to attract top talent from the industry on those principles.
And to be clear, my implication wasn't that you didn't care about your talent or anything like that. It was more the degree to which talent was a constraint for your particular team.
ML is interesting because it's not like simple simple engineering where you learn something new packages. Like honestly, Sam, I try to keep myself up with technology. By the time I like carve out time to do something, and I'm like, yes, this weekend I'm going to study that, and then a new technology or new thing is out, right? I was looking at this 2022 Gartner paper where they were talking about some trends and everything, and I just wrote down like 5 or 6 things that I'm going to study in next 1 or 2 months. And then I started talking to my colleagues at Capital One, and I was like very impressed by some of the things our team and they are already doing, which is on the Gartner uh, next 2 to 5 years. So there is, in ML, you need to keep yourself like always learning and growing.
It's tough, moves quickly.
It's fun.
How do you think the way that machine learning is approached there at Capital One will evolve over the next, I don't know, 3 years?
So it kind of goes into what I was saying, like the 2022 Gartner study with the hype cycle for data science and machine learning. So as I mentioned, I was going through that and what it suggests companies or industries are going to be moving in next 2 to 5 years. And I'm very pleased to see Capital One is pursuing that. Earlier we talked about like Capital One is trying to build this ML coherent ML ecosystem, right? And what we are trying to do is that how we talked about my peers team and my team, we're trying to serve all personas. If you will be citizen data scientist, traditional data scientist, right? And what we are trying to do is we are trying to centralize our platforms, we are trying to democratize, we are trying to build do reusability of libraries components, right? So what we are trying to do is like ML available, accessible, and leverageable for every for all, with necessary guardrails and responsibility in place. That's where I see we are growing. There is like a lot of emphasis on overall like automating the overall machine learning development life cycle, right? Building robust pipelines for ingestion, data ingestion, sophisticated feature platforms, training and execution platform. I'm thinking all the things my peers are doing and my team is saying, so I'm thinking and asking. The CIDC, platforms, the feature and model monitoring, right? We are investing a lot into ML ops extensively, ML observability. Another interesting thing is like provisioning clean data and governed access to data are important these days. Cost optimization, scalable multi-tenancy platform, as you said, and like multi-region. So stabilizing our platforms. We are also researching a lot of things around graph ML, synthetic data set, which I mentioned before, ML ops, model ops, transfer, and federated learning. And then because we are in governance, we are in the governance state, so I would want to say again and again, like we have a model review office, and then we continue to invest in our standards for governance, transparency, and explainability for models. So I see like Capital One is on the bleeding edge of ML, and I'm very proud to be here, and I'm very impressed by the work my particular organization and all my peer organizations are doing at Capital One.
Sounds like you got a lot going on.
It's fun. It's fun. It's an awesome journey we are on.
Awesome. Awesome. Well, Disha, thanks so much for taking the time to share with us a little bit about your team and what you're up to.
Thank you, Sam, for your time today. Much appreciated.
Thank you.